Hey guys, welcome to another video. So today, the last installment in the series and sequences financial maths topic. So we've gone through three videos covering investments and superannuation, home loans, and loan repayments. And the last one we did was annuities, which it's a for actuaries and people that study financial maths at uni. It's very much a diluted down version of the maths and the calculations that you do there, but it's in syllabus, so hopefully those videos were quite insightful. So today I want to do a few examples mainly around loan repayments, but the first one actually it's one of my favorites where it's got both the investment side and the loan repayment side all wrapped up in one HSC question. So some of the questions get quite I guess involved towards the end, but hopefully it's not too bad. So it's good, good broad coverage of some of the questions that can be out there. So let's start. So these past paper questions are, especially the HSC ones are repeated, right? What you'll see is for Year 12 students, do not be surprised if a question like this actually appears word for word, even in your past papers, in your trial papers, in your test assessments throughout the term. So it's because they're nice questions, and sometimes your teachers basically just want to use them. And if they're already there, they might change a name, they might change a number, but structurally it might be the same. So this one's nice. From the HSC 2010, you can see it's in two parts, and just look at the mark allocation, right? We're talking 7 marks, 7% of the test, one, well, in this case, 2 questions, but financial maths. The first one, you can see if you've done the reading, when Chris starts a new job, 500 was deposited in superannuation fund at the beginning of each month, compounded 0.5% per month, 240 months, right? Show that pig was that, guys. That is a classic savings question. When I'll draw a diagram for this, right? You don't need to draw the diagram, I guess, in a test, but for me, it's good to just visualize it. And then the beauty about this is, so Chris is saving up to retirement, so it's a savings question up to that point. Thereafter, he starts withdrawing, right? But what happens is it doesn't just withdraw, right? It grows with a bit of interest, withdrawal, grow. It actually mimics a home loan question thereafter. So it's actually two for one. So we got to show that the home loan equivalent question, or in this case, the amount in the fund is equivalent to that, and then how many months, right? So we're solving for n, which is interesting because a lot of times in these questions, there's not a lot of variables. There's n in this case, which is if it's a power, we use logs. Sometimes you're solving for the repayment amount. So it's very sort of it's classic, but I like the fact that it's got investments and savings. And home loans all in the same question. So let's attack this. Well, we got here $500, 0.5%. How many months? 240 months. Cool. So the diagram to help you and myself, I guess, visualize this, right? So you got time 0, time 1, time 2, and then 240 at the end, 239, 238. So he puts in $500 at the beginning of the first month. That gets compounded at 0.5% for 240 months, right? Pretty sweet. Next one, I'll just maybe do 2 of each side. So that one there is put in a month later. So it's only got 239 months of compounding, blah, 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 in the middle here. Now, the second last payment is made on the 230 at the beginning of the second last year, 238 in there. So 500. And he gets 2 years of compounding, right? And then the last payment gets made there. Nothing too fancy about that. 1 year of compounding, right? So if I add up the stream of numbers on this side, that, right? That total amount there should be my total amount, in this case, the variable P, right? So let's do this and then develop the sum of a GP and then solve it for 2 marks. So I'm just going to rewrite this. I always write it with the smallest power first because that's nice for my GP. It's always good to have it growing rather than shrinking. 0.0052. So right now it's just automatic robot mode, right? Where you just basically know exactly what you want to do, what you want to see. You just got to get it. So 500 there, 1.005. What was that now? 239. And then last but not least, the last piece there, 1.005, 240. Take out anything that's common in this case. You can take out the 500 and the 1.005. Yeah, and then you know when you factorize this that it's 1 plus one of these guys now, because I factorized one out, plus all the way, second last one becomes 1.005, 238, taking one out, plus 1.005, 239, taking one out. Right, this guy is a GP. How much vertical space do I have? Yeah, not bad. Where A is 1, the ratio is 1.005, and N is 240, right? Because it's 239 there, but there's 1 at 0, so 240. Yep. So, you know, this is very textbook, right? Very textbook. There's nothing fancy about this one so far. Yeah, nothing fancy about this one so far. So 1.00, so R to power of N minus 1 over R minus 1, right? Be absolutely clear. So this stream of numbers through the GP becomes this guy, right? Yeah, punch in the calculator. You'd be hard pressed not to get the number, right? Like you have to get the number. So maybe satisfy yourselves that that is the number, and we will just use that going forward. So that's, maybe I'll go, actually put the letter P there as well, because that's what they were asking me to find. Done. HSC 2010, 2 marks there. Hopefully not too bad. Yeah. So even if you couldn't do part 1, you can actually use that value of P to do part 2, right? So it's a very common thing that I say to my students: if you can't do part 1 and you need it for part 2, just use it, right? Don't lose marks on both part 1 and part 2. So part 2, what do we have? So at retirement, he withdraws $2,000 at the end of each month. So it's basically a loan, right? So basically that's amount, you know, if the loan analogy works, that's the amount that they borrowed. The monthly repayments is $2,000. Interest rate's 0.5%. So let's carry this forward. So, you know, I'm not going to try to squash it. I'm just going to copy this, delete this, and we are cooking. All right, again, it's going to zoom in. I always write neater when I zoom in. So where we are. So part 2, part 1, right? AN call. So remember, we have to probably demonstrate this point to A3, and then say the pattern looks like blah, right? So A0 is just P, right? That's the amount at retirement. And then what happens is that grows with a little bit of interest minus $2,000, right? Oh, sorry, that's not A0, that is A1. Yep, done, all right? And then A2, right, starts with A1. Once again, I'm on, like, you know, autopilot mode here. A1, we don't need that square bracket yet. 0.005 minus another lot of 2,000. I know that this guy gets substituted into this value, right? So then I start doing my substitution and expansion to get what I want. Yeah, one thing to keep your eye on is, see this, there's no fractions here, right? So when I apply the GP, normally I have a term on the bottom, but if it's a nice interest rate like this 0.005, you can then do 1 divided by that that nice nice interest rate to get like a whole number, which is what they've done, I believe. You know, I'm just going to freestyle and just keep going on autopilot mode. I don't think there's anything in this question right now that is too out there that will make this textbook approach incorrect. So let's see. Right, so I'm just going and saying, therefore, A2 is at. Let's do it once more for A3, right? Just to make your teachers, well, I don't know. It depends on your teacher. I always say to my students, go to A3 because then you can really demonstrate the pattern for you to extrapolate to AN, right? So once again, there, this guy falls into here, right? Nothing I've done right now is out of the ordinary for a loans question. The only thing that's out of the ordinary is the context for this question. I like it, right? Basically, upon retirement, yeah, they start spending $2,000 a month. And this is the calculations, right? It's actually, you know, pretty real as a concept because, you know, people that save for retirement, let's say you save for retirement, you get like $5 million and you want to know how much you can spend each month, right? Yes, in real life, the interest rate changes. Yes, in real life, the amount that you change can change as well. But the concepts are very similar, right? You basically have, you know, they call it savings and then drawdown, right? Yeah, retirement period. So, okay, let's see. So let's put that in 1.0053, right? Remember, the T part, right? The interest part always has the same power as the N, while all the monthly payments, the highest one starts off with 1 less than the N, and then it sort of dials down thereafter. 1 minus 2,000. All right, guys. Yeah, with that pattern in mind, I'm gonna shift this up so I have a little bit more vertical space. I can say, therefore, AN has the same pattern, just be careful, right? When it's A3, that power is 3, right? And then each of the powers of the stream of numbers drops, right? So the way I always say to my students, this term and these terms are different, right? Consider them in two sort of buckets, where the first term always has the same power, 5 in this case, as N minus, and then this string, right? This string you start with the power that's 1 less than N, and then you sort of go all the way to 2001.0005 power 1 and then minus 1 without any powers, right? So then we apply the sum of a GP to this guy, right? Yep. So we leave the first term untouched, minus factorize everything, right? And so you get 1 plus 1.005 plus all the way to 1.005 n minus 1, right? Just like before. Just like before. Yeah. Stick with the same colors, even though I used green in the last question. That's fine. This guy here is a GP where same A is 1, R is 1.005, and N is, well, N, right? Because there are N terms, N minus 1, there's 1 and 0, right? So let me see. This guy then equals to P 1.005, oops, 5N minus 2000, apply the sum of a GP, where it's like 1, so I'll ignore the 1, so it's at 1.005 to the power of N minus 1 all over 1.005 minus 1. So what I was referring to, so that just to be clear, that this is some GP. What I was referring to before was that this guy here on the denominator there is 0.005, and in my question there is no fraction, but what you'll find is that if you take 0.05, if you take 2000 divided by that on your calculator, I think it's 400,000. Let me just check that, right? So 2000 divided by 0.005, 400,000, right? That's how they got the 400,000 there in the question. So if you sort of clean this algebra up a little bit, you get this guy and this guy becomes 400,000, right? 1.005 n minus 1. Now I'm going to do 2 steps in one, if that's okay. I'm going to expand this, and you can see it's P times this minus 400,000 times this. So in the question, they've just factorized it, right? They factorized the 1.005n out. So let's just get to the final answer. So therefore, AN equals to P minus 400,000. So they factorize the 1.005n, and then that times that plus 400k. So, I mean, I didn't really do much thinking there. I just went on auto mode because it is a very textbook question, but the context is a bit different, but the mass is very predictable. Now, generally when you get to this point, right, some questions basically ask, it depends on what's missing. In this case, P's not missing, where we found it with leverage P, N's missing, right? The number of months where in this case, the context is they'll run out of money. Normally you repay the loan, right? So what we do is, I'll copy this again to another slide. All you got to do is set the AN to 0. That's when, in this case, they run out of money, right? So let's do that. So quite simply for question 2, part 2, AN is 0 is when they run out of money, right? So then you're just solving this question, and you need to use logs because it's got in there, right? So P, when you, I suspect they'll need me to use, I'm just going to use a number in here, right? So use a rounded off figure, right? Don't use one that's in your calculator. I guess you don't need to. So let's say P minus that times 1.005 n plus 400,000. Set that to 0. Yeah, I'm trying to make this guy the subject, right? So I'll make this term the subject right now by minus 400,000 over, divide by that guy, and you get therefore 0.005n equals to negative 400,000. Now it's fine if it's negative. So for those of you that are thinking, well, you're going to log both sides, you can't log negative. Well, you can. So it's not going to be negative because P is smaller than 400,000. So the denominator will be negative as well. So when you do log it, it's actually fine. So in this case, n equals to log 1.00. I'm just going to show you the full working, right? So that over P. So both that value as a fraction will be positive, right? Yep. So then if you change the base and then punch in your calculator, I believe the answer is going to be 174.1-ish, right? So how many months? So basically, now I always say to my students, once you get that, it's actually no hard rule of whether you round up or down. It's actually to do with the context of the question. Some questions go, when, in this case, right, if I said to you, when is the last month they have money, then you round down. When's the last month they run out of money? You round up, because on the 175th month, they'll run out of money. So for this one, the answer is 175, 75th. How many months, right? That's right. So it's always dependent on the rounding depends on the context of the question. In this case, they want you to run out of money on the 175th month. So hopefully that was okay. That's a HSC question. Let's do a slightly different one. So I'm just plug in my battery for screen turns blank. Okay. So this next question. All right. So I had 4 questions planned. I mean, these ones take quite a while. So let's say we maybe do 3, right? And if needed, right, if I get some requests, I'm happy to do more. So let's do this one. Oh, maybe this one's the same. So how many months? No, let's do the next one because this one's how many months. Let's do one where from Sydney Grammar where we're finding something different, right? So it's not too, it's a little bit different, right? I just want to show you a bit of variety, and then I want to really do the HSC 1998 one, which has been copy and pasted into multiple trial papers. And for those that have seen trial papers, you'll see the next question when I do it, that it is a classic. Guys, first thing to note about this Sydney Grammar question: look at the marks, 8 marks. Wow, right? So you must be able to do these, right? So I think it starts off pretty textbook, right? Pretty textbook. So let's see, 800 grand, borrows, interest rate, 24 equal monthly installments. Yeah, 24 monthly installments. So in this case, you're not finding N, you're finding M, right? Which is the monthly repayment amount, right? So they want you in the question to go up to 2, great. Extrapolate, fine, okay. For the first 3 parts, pretty textbook. And then it's the 4th one. After paying 10 installments, the company decides to increase the repayments. Find how many more months. Is it increased, by the way? Don't know yet, actually. Maybe change. Right? How many more months does it? So if it's increasing, obviously the debt runs off faster. But if it's less, then it runs off slower. So I like that. All right. I just wanted to show you an example of how to tackle a question that changes midterm, right? You got to be able to react to. Sometimes the interest rate changes. Sometimes the, in this case, the monthly repayment changes, right? Sometimes you might borrow more, right? Or how does that work? So, right, you got to be able to react to it. So in this case, part 1. So I know A0 is the loan amount, 800,000, right? Very textbook, right? Questions 1, 2, 3. A1, once again, wait, this is monthly. So, ooh, be careful, right? If it's monthly, you just got to convert that to monthly rate. So divide by 12 to 1%, 0.01. I think, yep, cool. So then it's 800,000, 1.01 minus M, right? M's a monthly, yep, cool. Done. A2, ooh, this is going to save you a lot of time because they only want you to do A2. Start with A1, compound it, minus M, then sub this guy into, yeah, right. You get A2 equals to 800,000, 1.01 minus M, compound, minus M, cool. Rainbows, yep. Rainbows that, please. And you get what you want, right? Oh, yep, so you get 800. Sorry, what threw me off slightly was, I was like, where's the powers on? They just punch in the calculator. Well done. Power 2 minus M 1.01 minus M. Yeah, I don't like this, how they've combined the M's, right? Because it sort of breaks the GP, but then they want you to do GP. So like, what? Why are they doing this? So, guys, I reckon if you punch this into your calculator, you should get the first part, right? And if you factorize M and you basically put the 1.01 with the 1 together, you will get the second part, right? So then I'm just going to copy. Yeah. So, you know, like when you set questions as a teacher, you're always going to ask yourself the question, right? For part 1, if you get the students to prove something, in this case, prove this statement here, does that flow on to the next bit? Because generally it's a story that you tell, right? Part 1, part 2. This one, the story leads you down a different path because you've added together the 2 M's. If I was to extrapolate, I can't extrapolate that, right? What I can extrapolate to get the next part is actually, I need to go back a step and use this, right? I need to use this. That's really what I want to use. I don't want to use, so I don't know why they made me do this, right? Yeah, so I'm not going to use blue. Blue's fine. Blue gets me my 2 marks or my extra mark at the end because that's what they want me to prove. But actually, when I do part 2, right, I'm going to go back to the green. Yeah, so not a big fan of the way this story is told, right? It's just led me down the garden path for a bit. Let's go back up here. So I'm going to extrapolate and go, therefore, AN looks like it's 800,000, right? 1.01 to power N minus a series of payments. I think this question is a bit weird, but yeah, it's asking you for A2 and it's asking you for a weird A2. Normally it should be asking you for A3 because, you know, then you can tell the pattern, right? And you can tell the pattern. So, you know, different teachers, different approaches. I wouldn't have done this, but that's just me. Right. Yeah. Guys, once again, you got 2 elements, right? So, you know, right now it's still pretty textbook. Let me just have a quick look at what they want. Yep, that looks pretty textbook. They just made him the subject at the end of the period. Excellent. So let's factorize. All right, so nothing here is not textbook. Apart from that blue step, right? I've already spoken enough about that. Factorize that 1 plus 1.01 plus all the way to 1.01 n minus 1. That is a GP, isn't it? Yeah. So grab my pink pen. That's GP. A is 1. R is 1.01. N is N. Right. Just moving at a bit of pace because I don't think this warrants much description because it's textbook. Very, very textbook. Minus M. 1.01 to the power of n minus 1. 1.01 minus 1. Now let me just have a quick gander. Yep, becomes yep. Oh, I think yep, that's fine. Yep, perfect. All right. I was looking at the 8,000, how to get to 8,000. You see it here, right? It's because of this fraction, like I did in the last question. That is like 0.01, which becomes 100, right? Yep. So when I combine the m with that, just to clean this up a little, 1.01 n minus 100 m, 1.01 n minus 1, right? That's an. All right, guys. So if that was textbook, right? Yeah, I now need to find the value of the monthly repayment by looking at this, and I say to myself, when n equals to 24, a 24 is 0, right? Whole loan's paid off. So by doing that, I'm just going to sub n equals to 24 in. So 0 equals to, right? 800,000, 1.01 to the power of 24. So anytime you see n in that box down here, let's plug in 24. So minus 100m, 1.0124 minus 1, right? What am I trying to do? I'm trying to make m the subject. So chuck that second piece over to the 0, make it positive, then divide everything else over. Therefore, right? I'm sure your teacher wouldn't mind you going then, just go 800,000, 1.0124 divided by 100m. Oh, 100 only because the m is made the subject. 0.0124 minus 1. Let's have a gander. Perfect. 100s cancel out, and I got it right. So basically, they're saying the 0 goes away with 100, and therefore m is 8,000, 0.0124 over 1.0124 plus 1. Yeah, exactly what they want. Is that all right? So very textbook there. And then I think for 1 mark, they just want me to punch in the calculator. All right, perfect. Nearest door. Let's do that. Yeah, because I suspect I need it for the next part. So it's might as well. For part 3, if you punch it into your calculator, what you guys get? 37 dollars, 37659, I believe. Yeah, but don't trust me. Punch in the calculator yourself, please. Yep. All right. So that's first 3 parts, right? Pretty textbook. Yeah. So let's do part 4 now. Part 4. After paying 10 installments, company decides to ramp up, right? It was 37,000, now it's 60,000, right? So I should be expecting, instead of paying off in, so after 10 installments, so normally it'll take 24 months. I've paid 10 months. I'm expecting it to run off faster than 24, right? Because I'm paying more. So let's see, let me copy everything. There it is. Zoom in. All right, let's see. So what I'm going to do after paying 10 installments, so I need to work out the loan at the 10-month mark and then effectively create a new loan with 60,000 being the month. And then I'm now solving for n. Can you see that? So in this question, they're basically giving you a new value of m. Yeah, and they're asking you number of months, right? they're asking you to basically go n equals 2, right? They're basically redefining a new loan. That's how I always teach my students. I basically say to them, if something happens in the middle of the term, you basically calculate the loan up to that point, and that loan amount effectively becomes a new loan amount, right? So using our formula from before, let's get that new loan amount, A10. I know it's going to be 800,000, 1.01 to the power of 10 minus 100. Now, I got the loan amount from before, sorry, the monthly amount from before, so I'll use it rounded. So what was it? 337,659 times 1.01 to the power of 10 minus 1, right? So that's a straight copy of the formula for AN that I derived in the last question. If you did this correct, and please don't trust me again, do it yourself, 489,701, right? So guys, that becomes our new loan payment, right? That becomes our new loan payment where, maybe for you guys, for simplicity, I'll just let this equal to P, right? Let's let this equal to P. Yeah? So if this is our new loan, I'm going to reset, right? I'm going to reset, I'll call it B0 equals to P, right? So B0 is the new loan amount, right? Just maybe I'll label that for you just in case you're like, what's B0? So new loan amount. Yep. So what I'm going to do, I'm going to derive a formula now and then solve for the new N. And I know that whatever N value, let's say N equals 5, I need to add that to the original 10 because that's how many months in total the company will pay. So they've already experienced 10 months and now for another N, right? Let's see what this is. So let's develop a loan series based on this. So B1 would be P times the same interest rate, 1.01, the power of 1 minus 60,000 now. Yeah, 60,000. So I love this question because it switches. Before you're finding M, now you're finding N, right? So I know, let's do this. Bn equals to, same deal before, right? 1.01 to the power of N minus 60,000. And just for your sake, I'll insert the sum of a GP so I don't, rush too much. It was like this, right? Over that, minus 1. Yeah, same deal as before. That was 100. So if you multiply that up, right, just to combine this, and that's 100. So 60,000 times 100 is 6 million. Is it? 60,000, 600, yeah, 6 million. In minus 1. Now, 6 million. Let me just make sure the math is sound. So what do I want? I now know that this is Bn, right? What do I want to solve for? I want to solve for the value of N, right? I need a power N because that's going to be my number of extra months, right? So I'm going to set this to 0. Because that's when this guy runs off, right? So let's see. Can you picture the rainbows at play here? Then just like a previous question, I'm going to factorize a 1.01n, so it becomes like 1.01n, factorizing P minus 6 million. 6 million and plus 6 million equals 0. So when I move this over, it'll be negative, but remember P is much smaller than 6 million. So it will be negative as well. So then I get 1.01. Our N will be negative 6 million. That's fine to be negative, right? Because the denominator will be negative as well. Yep. And then once again, I would apply logs to this. Change your base, of course. And if you did that on your calculator, I believe you get 8.5. Now, once again, what's the context here, right? It's 8.5. So in the 9th month, they'll pay it off, right? So therefore, N is 9. Now, so what's my answer? It takes 9 months extra from the 10 to pay this off. Normally, it'll take 24 months, but now it's going to take 10 plus 9, 19 months. So therefore, the answer for this one is 19 months. Is that all right? Yep. So I like this. I like it when the question changes inside the term, right? In this case, you're paying more, sometimes interest rates, sometimes you're paying less, sometimes there's a fee. It's great. Guys, I want to do one more question, and it's a classic, right? It's a classic. It's a classic. Firstly, the question, I don't know where you've seen this before. It's the fish question, right? So it's a loan question hidden in the context of a fish farmer, right? Where you can see that at the beginning of 1st of Jan 98, he's got 100,000 fish. So what happens is every year the fish increases by 10%, and then he sells 15,400 of that fish to a retailer, for $10. Yeah. So forget about, in this case, it's hard because there's number of fish and then there's a price to it, right? It's like a dual element. So the context shifts from loan dollars to number of fish. So the number of fish follows the loan patterns, and then the price comes after, right? Just to make it a little bit more confusing. So let's do this, right? So let me highlight this. So at the beginning of that, it's got 100,000 fish. Each year he supplies. This is like this supplying of 15,000. That's M, right? Yeah. $10. Okay. I won't deal with that yet. And increase it. This is almost like a compound rate, right? 10%, right? Because each year, yeah, it grows by 10%. So let's see what we have to do. Find the number of fish after the second harvest. So end of the second year. So you get 1, 2 years. So this is like effectively finding, right? This is like finding, now they're using F, right? It's like F2, right? And then show that. So up until there, if you can understand it, that is textbook, right? When we'll sold, actually that's also textbook. When we'll sold all the fish. So when Fn goes to 0, right? So in this case, Fn goes to 0. I like that. I like that. And what will his total be? Ooh, that catches people off surprise, right? Catches people by surprise. And then the last one, each December retail. Oh, I like that question. Let's tackle that when we get there. So part 1. So F0, how many fish does he have at the start? 100,000. At time 1, the 100,000 fish grows by 10%, and then he sells off that, right? Nothing too fancy about that. F1 done. F2. Starts with F1, grows a bit, minus 15,400, right? So then just like before, this guy comes into here, sub it in. Sorry, 1.1, yeah. That, expand that. They just want me to find it, right? And they just want me to punch this in. So if you did this on your calculator, squared minus that. Yeah, so then they're not asking me to leave alone, they actually want the number. I believe it's a nice number anyway, 88660. Please check that on your own with the calculator. That's how it should work, yeah? So that was easy. That was it's probably 1 mark, or 1 or 2 marks there. Now they want me to extrapolate this for Fn, so I know Fn equals to, you start with your original 100,000, 1.1 to power of n minus, and this is like the loan repayment. So that 1.1 to the power of n minus 1 minus. I always like to do 2 on this side just to give it a pattern, right? Guys, just like before, that is the growth and that is the cut down, right? Which follows a GP. The cut down follows a GP. So let's go there. Equals to, let me just check the numbers. No fractions. Once again, they would have divided by a nice number. Right, in this case, it is a nice interest rate. So factorize the 15,400 out, reverse the order 1 plus 1.1 plus all the way to 1.1 n minus 1. That is the sum of a GP. A is 1, R is 1.1, n equals n, right? What's going for you in this question is that the numbers are quite nice, right? 10% interest rate or 10% growth rate of fish, not interest rate, right? But it's nice. And so I'm just once again going very robotic here. I know it's going to be 1 times 1.1 to the power of n minus 1, 1.1 minus 1. Right, this is nice because that is just 0.1, which is times by 10, right? That's how they get the figures there. So then all they want you to do additionally is to clean up this number sentence, times it by 10, so 4000.1 power of n minus 1. So once again, if you did your rainbows for that, then collected your like terms, you should get what they want up there. So let's copy and paste that. So therefore, Fn equals to, and that was from the last rainbow expansion. Perfect. Okay, nothing fancy about that. Pure textbook work, all right? Pure textbook work. Apart from the fact that the context is hard, right? So some people can't even start there because they don't know why the $10 is there or why we haven't used the $10 yet. Guys, we used $10, the $10, this guy here, right? $10 per fish. We're going to use that now, right? In part 3. So in part 3, when does a farmer sell all his fish? When that guy runs down to 0. So solve for n. You have that log equation that we always do, and then find what his total is. I'll talk about that in a sec. That's actually quite important for part 4 as well. So, all right, just going to delete that. So for part 3, maybe I'll shift over here, give myself a bit more space. So when Fn equals 0, right? I've got this guy minus 54,000, 1.1 to the power of n equals 0. So once again, I'm trying to solve for this guy, right? So pretty easy log equation there. So 1.1 n equals to, so this guy's on top. This time they're both positive, which is great. Therefore, n is log of this. Change your base for that log, and you should get, is it like 11 years? Yeah. So in the 11th year, he will finish, he will sell all his fish. Now, so the question really here comes back to, when we sold it, done that, what will his total income be? Now, keeping in mind, every year he sells his fish, right? He sells his fish. He sells 15,400 fish for $10, right? So therefore, income is always 15,400 fish times $10, and then times the number of years that he does it. We just found that he sells it like this for 11 years, right? So if you multiply the number of fish by the cost by 11 in this case, you get the total cost or total income to be, and once again, you guys punch this in, 1,694. So 1.694 million, right? Now, the next question is interesting, right? There's 2 ways to do it. There's trial and error, which always feels a bit unsatisfying for us. You and I, let's be heroic and explore the calculus version as well to do it. So I like this because it's like a max minimum question embedded in a series question. It's amazing. So each December, the retailers offer to buy the farmer's business by paying $15 per fish for the entire stock that's left over. When should the farmer sell? Okay, cool. So the way you picture this is, over time, there's two parts to his income, right? The first part is the income that he's made up until that point. The second part is whatever number of fish is left remaining, the retailers are going to pay $15 times that. So we're going to work out his income. We're going to define his income in two parts. We're going to define it as how much income he's made up until now, plus $15 times the number of fish going forwards, right? And that total income, we have to find the year that maximizes that, right? So it's not easy, right? You're just going to dig through it and say to yourself, let the income at time n, yeah, or let that be income. Now, let's say at after n harvests, right? So I'm just copying this after n harvest, yeah? So I know, right, at any point in time, right, there's two elements, right? There's how much has he made? Now, remember, how much does he make? If there's n years has passed, he's made, each year he makes that much times $10 times n, right? That's how much he's made up until now, up until the nth year, right? Plus the number of fish that he's got at that point, so Fn, they're going to pay $15 for it, right? There's two elements at play here. Can you see that? There's blue and there's green, right? Now, I'm going to turn this into an equation, like I'll sub in basically. I'll sub in this into here. And then we have the expression for us to maximize. Right? You can do it by trial and error, or you can do it amazingly using calculus, right? So let's see. So let me simplify this. So times 10 n plus 1 n times 15, right? Now, if you did this, rainbows, clean up the expression you get therefore, right? So I guess what I'm saying is if you sort of rainbow that, right, you get 2, 3, 1, 0, 0, 0, 0. That's this guy times the 15 minus, if you did 54,000 times 15, you get 810.01 1.1 and plus this guy. Yeah. All right, guys, you get that. You now have something to play with. Right? I need to maximize this. Now, assuming that this has a bit of a hump, right, where there's an n that gives you maximum, guys, method 1. It's called trial and error. Sounds better than guess and check. Yeah. So if you tested, I6 after 6, I believe if you sub 6 into the n values, you get like 1799. So what you're looking for is a hump, right? And a hump year, that's a maximum, right? 7036 I7. So I'm just guessing here, right? I got like, I got years to guess here. I know it's definitely less than 11, right? Because that's when it runs off. So I'm just guessing. You can guess at 4, start at 4, but just keep putting in numbers so you can find the hump. 5, 3, 9, and then I8. 1805 693, right? And by that, you can sort of see the hump. That's the biggest one, right? That's bigger than the one before and the one after. So the answer is therefore 7 years, right? 7 years. Does that make sense? The other way, if you want it, like that's quite quick, right? That's quite quick. Maybe that's the best way. But if you were heroic, right, using calculus, yeah, let's differentiate, right? Because we're trying to find maximum. Yeah, so if you've forgotten how to do maximum minimum, go see my other video. But this is how you do it, right? So I basically go d IN over DN, right? Constant goes away. Now, I'm differentiating and exponential, right? In this case, with a base that's not E. So the formula is all you got to do to differentiate that. Remember, exponentials don't change, but if it's a different base, all you got to do is just multiply that by ln of the base, yeah, times 1.1 to the power of n, right? So the base, ln of the base just comes down from that, right? That guy is linear, so nice and easy. Oh, I don't have any horizontal space. So I'm just gonna see if I can copy this guy over a bit. This guy a little bit over as well. Perfect. And then this guy differentiates to 154,000. Guys, I need to solve. All right. So you can see the only variable that's left is this guy. It becomes a log equation, right? So, you know, this guy goes over. Can I just skip a few steps? So just go n equals to log 0.1, right? Yeah, this guy's going to be on top. The 810,000 ln is going to be on the bottom. You punch that in and you should get an answer about 7.245. And then once again, the context of the question, do you round up or do you round down? In this case, you would probably have a look at these two options, right? You basically sub both 7 and 8 in and then conclude that 7 years is the winner, right? So I think this is a hard question because of the dollars, right? And the last question there, you have to redefine, sorry, you have to define an income amount that has the blue and the green, right? Income up until now and the future. And then you got to find the maximum. Quite tough, but hopefully that was okay, guys. That's financial maths in 4 installment videos. So if you like that, please subscribe to the channel if you haven't already done so. Give me a like. Tell your friends, right? This is free. Yeah, so, you know, just let them know. Here's a bit of theory to help you guys study. Otherwise, yeah, I'll see you at the next video. See you guys later.